Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
I think if I remember right, we were talking about how do we do the build and deployment of a Java application, right? I think in the last lecture, as part of that, we have built and deployed a Java application, right, which is connecting to the database MySQL, which is the AWS managed database in our case, but uh, it could be running in anywhere, right? So that the concept will be the same, right? So I think we spent some time in understanding the three-tier architecture, right? I think if I go back to this particular slide, so we have the, I think this is not the one which we talked about, right? Yeah. So if I look into this particular slide, right, usually the front end will be a React application. The backend will be your Spring Boot application, and then it has its own database to store the data. So what do you think, guys, out of these three layers, which one will be the more focused item? In the sense, where should I be putting more focus in terms of maybe from the DevOps engineer perspective? Do we need to, maybe even from the business perspective, right? Which layer that we need to put a little more concentration, the front end or the back end or the database, right? So of course the database is important, that is where my data is getting stored, but when I talk about the daily roles and responsibilities perspective of an engineer or even from the developer side, I would think that the backend is more important, correct? Because the backend, which I'm calling it as a REST API or the Spring Boot application, right? So that is where the actual business logic is being implemented. The front end is just getting the response and showing in a UI. The database just storing the data, but how the business should run, right? So based on the users options that are selected from the website, right? So what should be shown to the user, right? How to apply the filter, how to apply the sorting option, or maybe what kind of the content that should be shown to the users in the website. Everything, whatever you are doing, every logic is being implemented at your backend level, right? So that is a little important. In the sense, most likely the developers are putting a lot of effort in terms of developing the backend applications, and the DevOps engineer also will be putting more of efforts in terms of building and deploying the applications it into the backend layer. I mean to say the application layer, right? And sometimes you may need to put some effort in terms of upgrading the existing applications, or sometimes we may be putting efforts in terms of building and deploying the new applications as well, right? That's important. So that means now to run the Java application, right, we need to put effort in terms of doing the Maven build and running it in the Tomcat application, right? There's a significant process is there, right? It's not like if you get a Java code from the developer, just go and put it into the app server. No, it won't work like that, right? So the Java code has its own build process that we need to follow, right, in order to take that code and deploy and make it in a running state, correct? So today, let me put a little more focus on this application layer, application tier, right? How do we do the build and deployment of our application, right, to run it in a Tomcat? Of course, we have seen that in a high level. Just take the code, do the Maven build, you will get an artifact file, and you just give that artifact to the Tomcat application server, right? That will just run your application on port number 8080, right? But we'll put a little more effort on this now to understand, right, a few other items. So I just have got one other presentation that I prepared to understand this concept, right? Let's say I have one application which is the Spring Boot application in this case, right? So the developer is actually writing the code on Spring Boot, which is the Java framework to for this application one. Okay. So if you remember right, any developer should follow certain best practices when writing the code. The very first thing that the developer has to follow, right, the reusability, correct? That means the developer, as much as possible, try to put the code as a modular fashion, and that ensures that the reusability will be improved. I think we also follow the same, right? In the sense from from DevOps engineer perspective, right? When we develop the Terraform code or the Python code, right? So usually the best practice is to make it reusable as much as possible. That's how we put it as a modular fashion, right? Then you use that module whenever you wanted to utilize that particular, functionality, right? By passing the variables or whatever it is. And that will be applicable for any programming language that but the way how we are writing the code as a reusability will be differ based on the programming to a program. When it comes to the Java, right, how that is being getting achieved. Let's say the developer has to write a application one, and let's say there is a one more application called application two, right? So sometimes, there will be certain common code that needs to be used in app one and app two as well. Forget about the functionality, what these applications are doing, right? Because we are not a developers to go in deeper and deeper and understanding from the technical perspective, right? So we are trying to understand at just a generic high level layer. So let's say there are two applications that the developer has to write a code, right? Certain times there are certain number of lines of code or certain functionalities will be common in both applications. So if you want me to pick up a example, right? Let's say there are two different websites that the developer has to write, right? So let's say edUeki.com. Let's say there is one more website called Veloxy.com, right? As an example. So in those two websites, right, the sign up and sign in are the common functionalities, correct? So I don't want the user, sorry, I don't want the developer is writing that sign up and sign in functionality code in both applications, which is a kind of a duplication, right? Because no matter which website, the sign up and sign in will be working as expected. I mean to say the functionality will be common. Someone will register, it has to authenticate and give the permission to logging into the website. So that functionality will be common in any website pretty much. I don't want that kind of the common functionality built into each and every application, right? So the developer usually identify the common framework, and in the sense the 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 reusability code or the functionalities that will be inherited it into a multiple applications, they will identify them, and rather keeping that code duplicated in each and every application, they will prefer to, right, develop a one more application which we call it as a common framework. We can call it as a common framework, or we can call it as a one other application, doesn't matter, right? So let's say I have a one more application here. Common is the application name that I'm talking about, right? So here again, the developer will be writing the code, right, and keep it ready. Let's say common A is the code that is related to the sign-in functionality, that has only the sign-in functionality, how the sign-in will work for a website, right? So like that, what and all the common dependencies that may needed for most of the applications, right, they will be keeping it into a different application altogether. So in general, I'm just calling out that let's say common A, B, C. That means there are three different functionalities that are pretty much the same for most of the applications. Now they are keeping these three dependencies as three different applications altogether. Now let's say application one needed all these three applications as a dependency. Application 2 also needed all these three dependencies, right, in order to make it as a full-blown product. You see the advantages, guys. The developer need not to keep this common A, common B, common C functionalities it into both applications. No, just keep it as a separate. And now application 1 should use all these three. Application 2 also should use all these three. So that way, this common is in one single place, right? So the developer need not to duplicate the code again and again. But how that gonna work? Remember, right? I'm just comparing because that's easier. You as a DevOps engineer, right? If you're writing the Terraform code, right? Usually you specify in your code that from where the module code has to be get imported, correct? By writing the syntax called source is equal to and specify the module location, right? In which location that module is there, it will just get that code. If it is Python, usually we do import and the module name. That's how it will be importing that existing module source code, and that's how we are trying to reuse the code, right? So when it comes to the Java, right, we need to take the help of the JFrog. JFrog is the artifact management tool which we have used this already in order to store the Helm artifact, right? The JFrog can also store the artifact of many other build tools as well, right? So now when you get a source code for common A application, you take the Maven application, I mean to say you take the source code, you build it, and whatever the artifact that gets created using the common A build process, you keep it in the JFrog artifact tree. You build the common B application, you put that artifact into a JFrog. You build the common C application, you put that artifact it into a JFrog. That means what? All the dependencies that may be used by some other Java application, right? Those artifacts, I'm actually deploying it into a JFrog artifactory. The JFrog will be storing all those artifacts like a jar file or war file based on your project needs, right? So what do you think, guys? The common A, common B, common C that I'm referring here. So do you think these projects will be creating a jar artifact or a war artifact in general, right? These three will be creating a jar artifact, right? Definitely. Why? We know the difference, right? The war artifact in general will be used if your application is directly giving the web UI. In this case, do you think the common A and B and C are actually giving the direct web UI access to the end users? No. Why? This common A, common B, common C are not a full-blown product. That is just a simple sample, individual functionality that can be used by some other applications, right? So these will definitely be a jar artifact. Usually the war artifact is mean that there's a full-blown product which we are directly giving to the users to access it on the web UI perspective. But in this case, all these three definitely will be a jar type of artifact, and of course, the developer will take a decision, right? What kind of the artifact file that has to be created, but I'm just calling out that, right? So these will definitely be a jar files because these are not a full-blown application. Some individual functionalities are being developed here. Now, when you are building the application one, right? In the application one, you need to mention that, hey, as part of the build process, right? It needs some dependencies has to be downloaded. So in the pom.xml file, which we are no, which we have understood that POM is the project definition file, which has some information to the Maven how the build process should go, right? So When you get a source code for the application 1 from the developer, right, in the pom.xml file, it is mentioned that how to get the dependencies from the JFrog, right? That means, hey, from the JFrog, it has to download the dependencies of application common A, common B, common C. So we need to give some information there. We'll see how the syntax will be there in order to specify the dependencies that it has to download it from the JFrog, right? Uh, that's not a worry part, right? So when you specify the dependencies information and from which JFrog artifact that it has to download, that information is available in the pom.xml. Then as part of the Maven build process, Maven understands that, okay, these are the three dependencies that needed for this application. It will go and download them from JFrog. It will include them in the current build process, and then it creates a total of final package format, which is the artifact. So can I ask a question like this? In this process, right, let's say the application 1 is having a dependency with the common A, common B, common C. Once the build is completed, once application 1 build is completed, can I say that that build artifact is included the code base of application 1 plus common A, common B, common C, correct? Right? That's what is called as a packaging, right? The Maven will take care of downloading the dependencies from the JFrog and including them as well in the current product and creating a final artifact out of it. So that's how, right, the Java build process works. Now, let's say the application 1 you are building the source code, and the application 1 is depending on common A, common B, common C, and you are ensuring that that configuration is reflected in the pom.xml. Maven will take care of. Do you think application 1 artifact, because even the application 1 will generate one another artifact, right, the var or jar based on the requirement, do you think the application 1 artifact has to be get deployed it into a JFrog again? Yes, right. So the way how common A, common B, common C are dependent for application 1 and application 2, possibly, right, the application 1 artifact, right, the application 1 artifact may be a dependency for some other application. Let's say I have one other application called application 3, right? When the developer is writing the source code for application 3, possibly this application 3 having some dependency with application 1. Getting me? So in the application 3 pom.xml, the developer will mention that, hey, it needs some dependency. The dependency is artifact of the application 1 that has to be downloaded from JFrog. So when the Maven is building the application 3, it will look for the POM file, get the dependencies. Based on that, it will download the artifact from the JFrog, which is the application 1 artifact this case. And then the application 3 will be going for the build process and will be getting the artifact out of it. What does it mean by this presentation, guys? In the sense, when you are doing any Java build process, right, your Maven is actually downloading certain dependencies from JFrog to complete the build process. Once the build is successful, once the artifact is created, then that artifact we need to push it back to the JFrog again, because that could be a dependency for some other projects, correct? Are we good with this? It's completely a developer's responsibility to understand which application should have which dependencies, right? How to download them from JFrog, where are they, where are they stored in the JFrog? All these things will be known by the developer only, which we need not to worry about any of these what I am representing here. But we should understand how the Java build process works, right? Because running the Maven command is a DevOps engineer responsibility, right? So sometimes the Maven will fail saying that, hey, pom.xml saying that it need a dependency to be downloaded from JFrog, but that file is not found in the JFrog. You will get error. right? We should understand why that error is there, why the build is failed, right? To get some context about that, we should know how the overall build process works for a Java application. So at least if you know that context, we can go back to the developer and tell that, hey, the build is failed for the application 3. The reason is it is not able to download the application 1 artifact. Could probably application 1 artifact is not there in the JFrog and hence it is failing. It's their responsibility to fix the problem and give you the latest code for you again, right? But it helps you to understand why the builds are failing if it is not able to download the dependencies from the JFrog artifactory, right? So in this whole process, right, our job is as a DevOps engineer, your job is just to run a MVN command, the Maven command to build the source. That's it, right? So updating the pom.xml, right, and like like from which JFrog repository it has to download. Once the artifact is created, to which repository it has to publish it back to the JFrog. All this entire configuration will be there in the POM file, and that is a developer's responsibility to keep everything in the pom.xml file as per the need, which we are not touching the pom.xml file for any of these things. But we should have some idea that makes us little more confident and when we are doing the build process, because you can easily understand what could be the error that helps you to go and talk to the developers with a confidence voice, right? Good. So now being said that, now I wanted to do the build process one more time just to show you how this is working. So I just logged into my build server here, and in the build server, if I go to my Java login application sample that I have with me, right? So in this Java login app, if I go to the pom.xml file, right? So this is the pom.xml file that how it look like. In this pom.xml file, somewhere you can see something called artifact ID, right? Sorry, you can see here the name. So this particular line is telling about the name of the artifact, and the version is like what is the version of the artifact that it has to create, and the artifact type will be a var or the jar file. So all that information is available in the pom.xml itself. In the pom.xml, you can also see some property block which is calling out that which Java version would be needed to build this project. Usually, the code that is developed by the developer will be compatible for the specific Java version only. If the developer is writing the code for Java 1.8 version, you have to use the same version only, right, at the time of you doing the build process. If the developer has written a code for 1.8, and let's say you are using a different Java version for building, and the things will not work. And the developers will decide what could be the version should use for building this project. And that information is available in the properties section just to get to understand which version is compatible for this. Good. If I do a little scroll down here, so you can see the dependency block here. In the dependency block, you can see multiple dependencies that are needed for this project to go for the build process. So under the dependencies, you can see multiple dependency blocks like this, right? All these are the dependencies in the sense, if this Java project has to go for the build process, it has to download certain artifacts from the different location, and that's what is called as a dependency here. Under the dependency, there are two important lines that you see, probably three, right? The version is mean that which version of the dependency that it has to download. Artifact ID is mean that which artifact that it has to download as a dependency. Group ID will tell about this artifact has to be downloaded from which location. You see the location, guys, right? This is basically the folder structure. We'll get to know more details in a while. So this is the folder structure in general, right? It says that this particular Tomcat-Jasper is the dependency that it has to download. From where it has to download? It has to download it from the org folder. Under the org, there is a Apache folder. Under the Apache, there is a Tomcat folder. Under the Tomcat folder, there is a file called Tomcat-Jasper and with the version called 9.31, right? That's the meaning of these three lines. Maven will understand this syntax and will try to download this from the specific folder hierarchy as per the mentioned here. So that's how we can see everywhere, right? The dependencies are mentioned with the specific syntax like this. The developer know exactly what dependencies that the developer would be needed and right how to use them. We don't need to worry any of these, but I'm just calling it out just for for our information, nothing much. Well, so I'm saying that this dependency has to be downloaded from this particular folder, right? But where exactly these folders are there, correct? I mean to say from which repository it has to download all of these files, correct? By default, if you don't specify that this dependencies has to be downloaded from which specific repository, then the Maven will try to get them from the Maven repository itself. You see that the Maven repository.com, right? Maven repository is the default repository from where the Maven is trying to download all these dependencies, right? So I can simply go to the Maven repository to show you those files. Which is also called as a Maven central repository, right? So in the Maven repository.com, and you can see the folder here under the org, under the Apache, under the Tomcat, right? And there are certain files here. So Tomcat and Jasper is the file that I'm looking for, right? You see this, guys? So this is the complete path where this file is available, right? And here you can see the different versions here. So which version that you have been specified, that particular version of the file will be get downloaded as part of the build process, and that file will be included in the build, and then we'll be creating a package out of it. So that means by default, the Maven is trying to download them from the Maven central repository. Central is the terminology that we use. That means this particular files can be get downloaded from which repository. So that is the central repository, which we call it as. It will just download it from this specific location, right? The Maven central repository usually will have certain common dependencies that might be needed for most of the Java projects. Getting me? Right? But the specific dependencies which are related to your project. Every company, every project will have their own organization specific requirements, right? The functionalities. Those will not be there in the Maven central repository. Getting me? Right? Certain common dependencies that will be pretty much public, pretty much will be the same for across the organization, across the companies, across the projects. Those type of the common dependencies are already built and kept into the Maven central repository, which we can download it and go for the build process. But anything very specific to the project will not be there in the Maven central repository, right? Those has to be get downloaded from your JFrog only, correct? Getting me, guys? Let's say in this case, probably application 3 has a dependency with application 1. Do you think application 1 artifact will be there in the central repository? No, right? Because this is your own application. right? You need to build it and keep it in your own repository and use that as a dependency in another project. So that kind of the custom application artifact should be get from your private repository, which is the JFrog in this case, right? So now, right? So how do I mention that the dependencies has to be downloaded from my JFrog, not from the central repository, correct? For this, the first thing is you go to your JFrog repository, right? You go to the JFrog account that you have. The first thing is you go and create a repository first. Let me go and click on quick repository creation. What type of artifact that you wanted to keep, correct? So I think previously I have used the type called Helm. So today I'm using the type called Maven. You see here Maven? I wanted to store the Maven artifact in the repository. So select the type here. We can see that the JFrog is supporting to store the artifacts of various other tools as well, right? Including the Docker images. Previously, I was using the Docker images in the Docker Hub registry, right? It is even possible to keep the Docker images in the JFrog as well, and we can see that here support. Anyway, for now the use case is I need to keep the Maven artifact, and let me choose Maven here and go for the next. Right, and just give the naming convention how you are expecting the repository has to be created. By default, you see that it is creating a snapshot repository and the remote repository and the local repository, right? We are already familiar about the differences between local, remote, and the virtual repositories. Let me go and click on create. It's done. Now let me close this. So if I go to the Artifactory tab here, repositories, maybe I'll go to artifacts here. So here I can see the ed libs release and ed libs snapshot and release local, snapshot local, right? By default, it is creating these repositories for you when you give that prefix, right? Just to call out one more time, right? Local repository is where you are actually publishing the artifact, right? And virtual repository, that is where you are downloading the artifact. Hope you getting me, right? So when I go back to the presentation slide here, when you are uploading the artifact, that should go to the local repository. When you are downloading the artifact, that should be coming from the virtual repository. Good. Now again, if you see here, right, there are two repositories ending with -local, right? Release -local, snapshot -local, right? So what is the snapshot again? So if you call out the multiple environments, right? Let's say the dev, QA, perf, and then the production, correct? So anything that you are using for the non-production, you keep it in the snapshot local. Anything that you wanted to use for the production, you keep it in the release local. That's how the people will be differentiating the artifact that will be used for the non-prod and then to the production. Are we good with this? Let's say when a developer is working on the code, right? There is no guarantee that the code works in a single attempt, right? Today, the developer will do some changes, one artifact will be created. Like that, the development will be keep on going on, right? There will be multiple versions of the artifact will be created during the development time. But do you think all those versions will go to production? Not really, right? So whichever the version that is properly tested, verified, validated, only that version will go to the production, right? So that means usually the snapshot local will have all the versions, whatever is happening during the development time. In the sense, the developer will give you one code. Hey, could you please build it? You build it, you publish the artifact to JFrog, you deploy it and test it. It's not working. Okay. The developer will do the change again in the code. Again, they will ask you, hey, please build the latest code. You get the latest code, you build it, you publish the artifact to the JFrog and you deploy it. It's not working again, right? Like that, there will be a multiple versions will be created in the snapshot at least. I meant to say the non-production. Whichever is properly tested will go to the production, right? That will come to the release local. Hope you are good on this, right? Now, once the artifacts are created, once the repositories are created here, the uh, local and the virtual repositories. Now we need to tell to your Maven that, hey Maven, these are the repositories that I have. Use my virtual repository to download. Use my local repository to upload. That is the information that you need to tell to your Maven, right? So now the time to configure the Maven settings, right? How it has to integrate with the JFrog. So let's say here I wanted to use the release repository, a release local repository to upload my artifact. So here, if you click on set me up option here, right, for your release local repository, it will tell you the details, how to configure your Maven, right, to upload a artifact to this release local. You'll get these details here. So if you give the credentials here and click on generate, the token is fine. Let's say I need a yeah, that's fine. So I wanted to use ED libs release. Basically, this is the virtual repository. So just click on this generate settings. Basically, it will generate some settings for you. You see, all these are the settings that are created for you, right? So let me copy these settings. For now, let me keep these settings in my Visual Studio Code. I'm just getting some information from the JFrog guys, how I can configure in my Maven. I just have generated the settings in the JFrog, how I wanted to configure my Maven. Now let me keep that settings in my Visual Studio Code for now. For example, this is a settings.xml file, right? So the file name is settings.xml. Let me copy paste the settings. Now, if I look into the settings file, right, it has the username information here. What is the JFrog username that it has to use for authentication and the password as well, right? Let me see what are my JFrog settings. Username and the password. It's okay. My username is cm@edwiki.in. Let me give the username here. Let me give the username here as well. Let me give the password here. As of now, I'm using the password as plain text only, but don't worry. We can use the encrypted password as well. We'll see that best practices later. So I'm just giving the username and the password that it has to use for connecting to my repository. And this is where you need to tell that it has to, Yeah, it has to publish to which repository, right? So let me give the repository details here. Sorry. The settings file has the details about the repository from where it has to download the repository. Sorry, download the artifact, right? So this is my virtual repository. So let it be the same. And this is the snapshot. That's okay. Release snapshot. It's all good, right? So just to call out that I'm mentioning that from which repository it has to download the artifact, and this is the virtual repository in this case. I'm good with this file. Copy this file. This file we need to keep it in the build server. If I go back to the settings file one more time, right, this file has the details about the central repository and the snapshot repository. In our terminology, the local repository and the snapshot repository. Remember, the local repository is for sorry, I meant to say the local repository is for the terms are changing here. The central repository is mean that right, that is for the production purpose. The snapshot repository is mean that that is for the non-production purpose. So it is asking the credentials for the both. What will be the credentials to use for the central repository, which is basically for the release repository, which we are using for production, and what will be the credentials that we need to use for the snapshot, which is basically the non-production purpose. Even if you do little scroll down, it has the details about the central repository, which is the release repository, and the snapshot repository, which is the snapshot again for non-production purpose, right? That's where it has the details double times. And yes, in general, the permissions will be vary from non-prod to the production, right? So we can have the separate set of credentials for production, separate credentials for non-production as well. Hence, it is asking the multiple details here, right? How it has to use. Obviously, the production will not be having much granted permissions, right? It will be little restricted. So that's how it works. In our case, I'm using a single account and the same credentials, so I'm just repeating there and there. But when it goes to the production, right, I meant to say when it goes to the real time, right, the central has a different credentials and the snapshot, the non-production has a different credentials, right? Good. And this is the username that I'm using for connecting or logging into my JFrog, and this is the password that I'm using for logging into the JFrog. These are the JFrog login credentials that you are using for logging into the JFrog account, which I'm giving to Maven. The Maven will use this username, this password to connect it to the JFrog. Hope this is clear. And as I see a question in the chat window, we are not creating the password here. We are telling to Maven that use this password to connect to the JFrog, because the Maven is running in my build server, right? In this build server, whenever you run the command, the Maven has to connect to the JFrog account, right? And this is my JFrog account. It just needs some credentials. So I'm just supplying the credentials in the settings file. It can use the credentials when it is connecting to the JFrog to publish or to resolve the dependencies. And if I go back to the previous lecture, right, I have shown you how to create a user account in the JFrog as well. Though it is the same account, same JFrog account, here you can see the new user option. This is where you can create a multiple JFrog accounts with the different privileges. Maybe you can create one for non-prod, one for production. That's where you will be getting two different usernames, two different passwords, one for the non-prod related permissions, one for the production related permissions that you can manage and configure the same in your local as well, in your settings file as well, right? That's how it works. Now, if I come back here, right, So this is the settings file that I need to give to Maven, right? Let me copy this file. By default, the Maven will be using the settings from the directory called .m2. .m2 is called as a local repository for the Maven purpose. Maven will be using this .m2 folder to keep all the caching related information and the settings related information there. The .m2 folder must be there in the home directory where the no, the Maven is configured. I meant to say the OS level home directory. In our case, I logged in as a root user, right? The root user home directory is /root, right? In the /root location, there should be a directory called .m2. Sorry, .m2. Inside the .m2 folder, you need to keep a file called settings.xml. Let me create a file called settings.xml and keep the settings over there. I'm keeping my settings.xml file in the .m2 folder, which is there in the home directory. Right? I'm done with my step number 1. Now let me go to my Java source code. This is my Java source code is there. Don't worry about this file, which I got it from now good, right? The second step is we need to tell to where it has to upload the artifacts. Go to set me up one more time. Sometime back I have created the settings file. Now you go to the deploy option here. You will get the distribution management configuration. You just copy this syntax. Let me keep this syntax in a temporary file for now, just to see is there any changes that I need to do. Let's say test.xml. Okay, so this is called as a distribution management. This settings is all about telling to Maven that to which repository it has to upload the artifact. You see guys, I wanted to upload to the local repository to the release repository. So looks good. I don't need to do any changes to this. Let me copy this. This configuration should be there in the pom.xml file. So open the pom.xml file. Let me go below. Let me remove the existing, right? So at end, right, you just keep this distribution management. That's it. Now the Maven will understand that okay, this is the repository where the artifact has to be uploaded, right? And then it will just use the credentials that were there in that settings file. It will authenticate to this JFrog and it will upload to this particular location, guys. Save it. I'm done. Now let me try to do the build process. As I see a question in the chat window that what is path of Maven? Let it be, right? In which folder you download the Maven software, that will be the path of the Maven, right? I don't want to give the hard-coded answers. I'm just giving more generalized, right? Because that is not a standard. Let it be wherever, right? In which path you downloaded the Maven software, and that is the path, right? So in this case, the path is already set, right? So I just need to run the Maven command. Because I already explained the way how we can download the Maven software, how to set the path, right? So now the path is already set, the Maven is running. Maybe for your reference, I can say that the Maven is currently downloaded in the Apache Maven bin location. Right? So this is the location where currently the Apache Maven is downloaded and the extracted, the commands are there. The command is already set to a path environment variable. So all what I need to do is now mvn command, right? So can you help me guys, what is the command that I need to use now to build my project? So mvn package is the command to do the build process. The mvn package command is to build the source and create the artifact in your local system only. But in our case, what is our goal? Our goal is to build the project and upload the artifact to the JFrog, right? That is what I'm expecting now, correct? In our last lecture, when I executed the mvn package command, the artifact is created in the target folder in your local system only, right? In the build server only. But today I'm expecting that to be in the JFrog. So for that, we need to run the command called mvn deploy. So the package is a command just for building. It will not use any JFrog. If you are expecting the JFrog to be considered here and the artifact has to be uploaded to the JFrog, then the command will be mvn deploy. It will take care of the building as well as uploading the artifact to the JFrog too. Now you see that it is actually trying to download the dependencies from the repository. From where it is downloading the from where it is downloading the dependencies, guys? POM is the file which has the details about the dependencies, which dependencies has to be downloaded. If the question is like from where it is downloading, right? The Maven is now downloading the dependencies from our JFrog only, correct? Always the dependencies has to be downloaded from JFrog. Once the build is successful, the artifact that is created, that has to be uploaded back to the JFrog. That's the whole concept. If you don't specify the JFrog, by default it will try to download from the Maven central repository, that is the public one. If you specify that, hey, this is the JFrog artifactory that I wanted to use, then downloading the dependencies or uploading the artifact, both will be right happen to your JFrog repository itself. Resolution or the download, both are same, right? So resolving the dependencies will happen from the virtual repository of your JFrog, and publishing the artifact will be happen to the local repository of, release repository of your artifact of your JFrog. Make sense, guys? So it is still doing the build process. While it is happening, right? There are two files that I have configured here, right? The settings.xml file has the credentials plus it has the details about the repositories from which repository it has to resolve the dependencies, and the distribution management is the setting which has the details about to which repository it has to deploy the deploy the artifacts. The settings file will be there in the .m2 folder as a default, and the distribution management setting, this block should be there in the pom.xml file. So if you closely observe this output, right, downloading from central, and you see here it is actually downloading from cmfax.jfrog.io, so on, right? This is the location from where it is actually downloading the required dependencies, and the build is successful, and somewhere you can see that uploaded to the central. To where it is uploading? It is uploading to your release repository, and this is the location where it is uploading in that repository. Let me see that information in my JFrog, guys. If I go to the JFrog and do a simple refresh, lot of process is involved, right? So if I look into ed libs release local, and you see there is a folder called com. Under the com folder, you see a folder called DevOps real time. Under the DevOps real time, you see there is a one more folder called DPT web. Under DPT web, you see there is a version called 1.0. Under 1.0, now you see that there is a war file. What is that I'm looking for here, guys? Artifact, right? The artifact can be a type var or type jar, correct? In our case, this is a var artifact, and I can see my var artifact file is actually uploaded to this particular hierarchy in this repository. So this artifact may be a dependency for some other projects, which I'm not worrying at this time. The developer has given the source code for me. I do the build process. Once the build is successful, the artifact should come to the JFrog. Then my job is done. The question here is, I said that ed libs release local is the repository where my artifact has to be uploaded, right? That is the setting that I have done in this distribution management, correct? But how the Maven know that the artifact has to be uploaded to this particular hierarchy under the com folder, under the DevOps real-time folder, under the DPT web folder, correct? So this structure where it has to be uploaded, this structure is maintained in the pom.xml file. If I open the pom.xml file, yeah, if I open the pom.xml file, you see here artifact name, artifact type, artifact version, and the group ID. This group ID will talk about the exact folder hierarchy that it has to follow to upload this artifact. The way how it works, right? Com is a folder, under that DevOps real-time is a folder, under that DPT web is a folder, under that 1.0 is the version folder, and then it has to keep the actual artifact file over there. Getting me now, guys? Why the Maven is uploading this file into this particular folder structure? This folder structure is actually mentioned by the developer only in the pom.xml file. Hence the reason it is just following this folder structure, right? But we just need to understand what does it mean by this group ID and the artifact ID. Good. Again, it's the developer's responsibility to mention all of these. I'm explaining so that it's very, uh, at least convenient for us to look through, because you guys are the one who will be running this Maven command to do the build, right? Once the build is successful, whether this artifact is there on my JFrog or not, how do you do the validation? So look for the POM file, see this group ID and the artifact ID. Accordingly, you go to your repository and look for this folder structure and verify the file is there or not. If the file is there, your build is successful. If not, something is went wrong. That's how this information will be helpful for you as well, though you are not owner of maintaining the pom.xml files. Now tell me, guys, if this artifact should be used by someone else, in the sense, let's say there is another application which need this artifact as a dependency. How will you be keeping the syntax in the second application to download this as a dependency? I'm just trying to show you the details here. So usually in the second application, I'm just showing it here only, guys, but it's not mean that I'm putting it here. My intention is just to give you some context to how the second application will be mentioned with the dependency of the first application. Okay, don't get confused. So in the second application where it may be a dependency, it will be like this. The developer will mention that dependency, right? And the dependency block has to be closed. Right? So this is how the second application will be configured with the dependency block. You see, this dependency block will tell that, hey, DPT web is the artifact name. I need a version 1.0. This has to be downloaded from com folder under that DevOps real-time folder. That's how the Maven will understand. So the Maven will connect it to the JFrog to the repository from where it has to download. Then Maven will follow this whole folder structure. Then it will download this file. It includes that in the build process, guys. That's how it will be. So I just wanted to show you the syntax, how the developers will be keeping the dependency blocks, right? Whenever they have some dependency to be downloaded from the JFrog, which is the artifact of some other project. I'm not doing this now. I just shown you the syntax, how it will be. If you go to the home directory, if you go to the .m2 folder, sometime back, I just have created the settings.xml, right? Now you see that there is a one more folder got created automatically, the folder called repository. So whatever is downloaded sometime back from the JFrog, right? All that downloaded files will be kept into this repository folder as a cache or as a temporary. Is mean that if you build the project one more time, let me do that. I'm just trying to build the source code one more time. The second time I'm building my source code, guys. I just wanted to see the difference. The build is success within 18 seconds actually. And if I go to the history of this build logs, right, it is not actually downloading any dependencies from the JFrog again. Why? The very first time when you build the source, the dependencies that it is downloading from the external repositories, those dependencies are kept into the .m2 folder. So if you go to the .m2 folder, in the .m2, if you go to the repository folder, this is where you can see a lot of dependencies that were actually downloaded as part of the build process. So the next time when you are trying to, it won't download again. Just take it from this local folder itself and go for the build process, guys. That will just improve the efficiency or the performance of the build time, right? It need not to download again and again. That's how this .m2 folder will be useful as a local repository folder for the Maven to resolve the dependencies. So can I use this statement now? The Maven will try to use the dependencies from the local repository folder .m2 first. If it is not finding them in the .m2, then it will try to download it from the external repositories like a JFrog, whatever you have been configured in your settings.xml file. Are we good with the statement, guys? Now, you can run a command called mvn clean. This command will basically try to delete anything that is already saved in the local .m2 repository. Sometimes you may have some latest versions that has to be downloaded. You don't want it to take it from your local .m2 folder, right? The mvn clean will just clean up everything on your local .m2 folder, so that now if you do a mvn packaging or the build process, it will try to download one more time. Why? The local is already cleared. So that is called as a mvn clean command. If you're interested to know more about the Maven, right, the Maven is following multiple pages here, right? So the Maven validate will basically validate the project is all up to date or not. Maven compile command will compile the source code. Maven package will just build the source code and keep your artifact in your local. Maven deploy is actually deploying your artifact it into your external repositories like a JFrog as well. So in general, you use either Maven package command or mvn deploy only. Maven package is just to see if the build works or not. Maven deploy is actually uploading your artifact back to the JFrog as well. So any command or any page that you execute, it ensures that all the above levels will be executed automatically. Just to give you more context about the Maven, how it is working here. In general, when you are mentioning the dependencies here, if you don't mention the version, then by default it picks up the latest version only. If you are very specific about the version, you have to explicitly call out the version which you are looking for here. That's how the developers will take care of, right, which dependency version that they are looking for. Now, whenever you get a code from the developer, right, definitely now we need to do the Maven build process to create an artifact. That artifact has to be deployed it into your Tomcat server to make it running, right? Second, guys. Sorry. Well, so I'm going to say, whenever you get a Java source code, right, just doing the Maven build and deploying it into your Tomcat is not sufficient. We need to do the code quality as well, in the sense how good the code is all about, right? Especially these application servers, right, that the developer is writing on. The developer has certain standards that they need to follow while writing the code. I mean to say, let's say the developer is writing the code for the sign-in functionality. If the sign-in is working, is not mean that everything is good, right? So, what is the case if the developer is giving the, sorry, if the user is using the username and password in order to logging into the website, are these passwords are compromised? Are these passwords are encrypted? Are these visible to the to the hackers who are is trying to got me? That means there are certain core standards that the developer has to follow to ensure that everything is working as per the organization standards. Okay, more of developer related things which we don't need to worry too much, but having that idea is really important. That's the reason I'm covering these topics too, right? So there is something called So there is an organization who is defining the rules, guys. Okay. Yeah. So I would say the WASP is the organization who is defining certain standards, the core standards. What are the 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 checklist that the developer has to follow while writing the code? It's not like you go and write a code and it is working. No, right? So this is called as this is a simple example PDF file which has the details about all the different practices that the developer has to follow. So the developer has to read this whole through and follow all these best practices, and accordingly the code has to be written, guys. There should be somewhere the exact checklist. Maybe the websites are keep on changing, possibly, but yeah. So why do why do we need to worry about this, right? When the code is given to the DevOps engineer, hey, please take my code and build it and deploy it. It's your responsibility to build it and deploy, right? As part of the build and deployment process, if at all, I mean to say, as part of the build process, your responsibility to perform the code quality analysis as well, right? And if the code is not meeting for the code standards what the organization has set for, then you should not go for the deployment process. You should straight away, stop the build process and inform back to the developer that, hey, developer, your code is not meeting the organization code standards and it cannot be taken into the deployment process. Getting me? That is where the developer has to understand what is the code review process and how to scan the code for the vulnerabilities, and if any. Of course, it's the developer's responsibility to write a code by following these different standards that you see here in the PDF, but our responsibility to check that whether it is compatible or not, whether it is compliance or not, and report it back. How are you doing that? So in order to do the code quality analysis, right, we need to use a tool called Sonar Cube. There are different tools are there who can help us to do the code quality check. Maybe I'll say that code quality tools, right? You see there are wide variety of the different tools that are available in the market who can do the code quality check. Gerrit, Veracode, right, and the Sonar Cube and a few other as well. Based on the requirement, based on the project, based on the programming language that the developer is using, organization, licensing, and other factors, there will be one code quality tool that will be picked up by that company, and we need to use that tool to do the check. Right, most of the times the Sonar Cube is the best choice to do the code quality analysis, but it could be any other as well, guys. Right, so if we are using the Sonar Cube for doing the code quality analysis, then I need to inform to Maven that, hey Maven, you please integrate with the Sonar as well and do the check. If the check is passes, then only you publish the artifact to the JFrog, or else no. Makes sense, right? What do you think, guys? The code quality check has to be done before it is publishing to the JFrog or after? Which one makes more sense, right? The code quality check should be done before it is actually publishing the artifact to the JFrog, right? So I need to inform to Maven that, hey, you wait for the Sonar. If the Sonar says the code quality passes, then only you consider that build to publish to the JFrog, or else don't do that. So how do you integrate the Sonar Cube with the Maven now? Right? The Sonar Cube is also available as the SaaS product, software as a service product. So if you go to the Sonar Cloud, right? If you go to sonarcloud.io, which is redirecting to sonarsource.com, that's fine, right? So this is the SaaS product, right? We can just sign up to the account and logging into the Sonar account. and just integrate the way how I integrated JFrog with Maven. I need to integrate the Sonar as well to the Maven. Then the code quality check will happen. It's so simple. So let me try to logging into the Sonar here. I'm logging in with my existing any one of the credentials. Now, so this is my Sonar account. I just have logged into the Sonar account here, right? And all what I need to do is create a new organization and create a new project. Which project that you wanted to, go for the scan, correct? So let me create a project first. So again, guys, so this is just for our understanding. You will never ever creating a projects in the Sonar in your experience, because this is a one-time activity and this will be done by developers most of the times, right? Now create a project manually. Let me choose the existing organization. This is a project name. Let's say DPT11. Now my project should be a public one. If I go for the private, I need to get the licensed Sonar Cube. You see some licensing cost here. So usually in the organizations, right, they will pay and get the license version. Okay. For now, let me go with the public. Just choose these options. Click on create a project. Choose your analysis method. I wanted to go for manual. It is asking that the analysis has to be done on which builds: Maven, Gradle, .NET, C, and few other programming languages. We need to tell that, right, it has to analyze the code that is the Maven project, and it has given you some details now how the Sonar can be integrated with the Maven. As part of this, you see some settings. Step number 1, we need to create a token. Step number 2, right, this is the token that you need to set up, and then it is telling that, hey, this is the syntax that you need to add in the pom.xml file. Then the Maven will use this information and then use it, do the or integrate with the Sonar. Let me follow this case. So this is the environment variable. Basically, the token that you see here, right, the one which I highlighted, will act as a password here. So it will use this token to connect it to the Sonar Cloud.io website and authenticate and publish the build results. Let me follow the simple steps. So on the build server, we need to set the environment variable. This is the token. Now you need to take these two lines and keep it in the pom.xml. vi pom.xml. In the property section, let me specify those two lines. Save it. Now it is asking me to run this command. You see the command here, guys. Let me copy the command as it is. Now let me run the command here. So this is now failed in terms of uploading or using the Sonar. The expectation is it has to show the results in the Sonar dashboard. Regarding JFrog and Sonar, it's kind of low priority items, guys. We don't need to be too much expertise on these things. But yeah, understanding the process is important, but the practicality is not that much priority item. Okay, it looks like there is a problem here. So let me remove the JFrog dependency at least to see if that is causing any issues. The problem here is anything that is related to the build process, right? Anything related to the build process, you can't troubleshoot by yourself alone. Getting me? Why? That could be due to the version incompatibilities, could be due to the code related issues. So the developer has to be there in order to solve the issues, guys. Right? In general, if you get any error, you need to contact the developer only. Hey, this is what the build is failing, why it is failing. Because it's not our responsibility to fix the code. You got me what I'm trying to? Okay, looks like there is a problem. So probably it could be the version as well. The SonarQube version is 8.0 and my code may not be compatible for that version 2. Could be the reason, guys. But yeah, we'll try to see working code and we'll come back and we'll run this code when we are doing the pipeline automation anyway. I have to come back to this again to show you how to integrate this in the pipeline, right? That time we'll run this one more time. So somewhere you can see here the Java lang and unsupported class version. Okay, hope you are able to see this right. Unsupported class version. So this is the issue with the Java runtime. And somewhere you can see has been compiled by more recent version of the Java runtime. This version of the Java runtime recognized class file version, something like this. Let me try something. Yum list Java. What I understood right from the error, look like it is complaining about the Java version. Okay, so which version of Java that I'm using? 1.8. Let me remove this. Yum remove. I'm actually uninstalling the Java 1.8 version. Let me install the latest Java version. Probably I will go for Java 11. Yum install Java 11. In general, you need to get these information from the developer guys, which version that should be used here. Okay. Now let me try to run the command one more time. I'll be on mute for 30 seconds, guys. Let this happen. Right, interesting. Yeah, look like the Sonar is good, but my Java code is not supported but for Java 11 version. Yeah, that's okay. Let me see if I have got something here. Not really. Well, team, so I think, yeah, let me get one Java code which is suitable for Java 11 as well. Sonar Cube Java requirements. Okay. Sonar Cube is expecting the Java to be 11 or 17 version. Good. But my Java code requires Java 8, right? So that's where some problem is there. So we'll try to get some common dependency version. So if that is works as expected, right, then it should give the result like this. If I go back to the Sonar Cube, maybe I'll just take the existing results. So you will get the results like this. You see how many findings are total, how many bugs are there in the code, how many vulnerabilities are there in the code, how many security related issues are in the code, right? Basically, it will do the code scan and report if any issues are there. Now it's the developer's responsibility to go to that issues and start fixing the issues, guys. You see here, all these are the bugs that it has identified, right? So the developer has to go to that code and see why this is happening, and it has to fix the problem. Once all the issues are solved, right, then only the Sonar will pass this check, then only the artifact will be published to the JFrog artifactory. That's how it works. Looks good. Anyway, it's not our responsibility to analyze this Sonar report and all, right? It's up to the developer. Our responsibility is just to ensure that Sonar is integrated with Maven or not, and it is able to publish the results or not. So if it is published, the developer will take it up. Are we good with this for now? Let me clear the screen. All right, team. So I think that's the uh, those are the information that we should be familiar about the backend application build process, especially the Java applications, how the Maven is working, how the JFrog is integrated, how the Sonar is integrated. Once all these levels or checks are done, finally the artifact will be created. That is something that you give to Tomcat, and it will be running it over there. Okay. And when it comes to the front end, right? When you get a Java source code, sorry, when you get a React JS source code, right? Because the front end always will be either the React or the Angular kind of. How do you build and deploy the React application? Now that's the next focus, correct? So the way how you have a specific steps for Java, how to build the Java source code and how to deploy. Similarly, right, there are certain steps are there how to build and deploy the React JS application that we'll talk in the tomorrow lecture. Okay, so that's the process. Now coming back to the questionnaire, guys, how to set the code coverage in the Sonar profile? It's a good question. That's something the developer will be setting the code coverage, right? How they are expecting the standards has to be compared, right? I mean to say, how would the Sonar know that the code is as per the organization standards or not? Correct. So what are all the different checks that the Sonar has to look for, and on what basis it has to tell the code is good or not? There should be some quality gate configuration should be done at your Sonar level, which will be done by the developer only again. But for our information, let me show you the option where that will be there. You see here the quality gate and it says that passed to. So the quality gate is the terminology that we talk about, right? Which has the details about the different standards and the security, and the thresholds that it has to compare. Okay. So let me show you the quality gate configuration. Yeah. You see the quality gate configuration here, and these are the conditions that it has to look for. Maybe I can go and click on create a new quality gate. Yeah. This is how the developer is adding the conditions, right? Basically, this UI is keep on changing, guys. Earlier, when I was working, it was a different UI, and this is little improved. Okay. Yeah, you can see the conditions here. So you can see if at all the duplicate lines in the code is greater than 3%, then you please consider that as a red flag. Okay, and if at all the security hotspots are less than 100%, then yeah, this is the threshold basically, I believe. Yeah, I'm just trying to see the one which is more meaningful for us to understand. Okay, because all these are developer related terminologies, right? Okay, you see here the vulnerabilities. Okay, so on overall code, if the vulnerabilities are greater than 5%, right, greater than 5 number, then please consider that as a red flag. Okay, like that we can configure the the coverage profile basically. So let's say the bugs overall in the code, if the bugs are more than 5, then please consider that as a red flag. Let's say when you say 5, if the bugs are only 3, then the Sonar will be passing the code because it is not meeting the threshold criteria, right? That's how it should be. But it's all about the developer's responsibility. How would they, how would they, configure this whole conditions? You see the number of comments, right? So the number of comments should be at least less than 5%. Then it will be considered something like this. Okay. But yeah, anyway, it's a developer's responsibility how to set up this whole profile on what basis, right? Their code has to be go for the scan and take a wise decision based on that. Which we don't need to be worried about it. Yeah, that's how it works. Any other questions, do let me know, guys, or else we are good for today. Today, the whole concept is more of the developer's activity from the responsibility wise, but we should be familiar about it, how the things are working as part of the build process. And let me open pom.xml. Probably I need to configure it one more time just to show you how exactly the JFrog is working. I'm just putting the syntax one more time, and let me keep the settings file one more time because I cleaned up all this information, I believe. Let me do settings.xml. Let me save it. Right now, let's say mvn deploy. Let's say the developer has given the code for us, and now we are doing the build process. Right now, it will download the dependencies from JFrog, and then it will create a new artifact out of it. The new artifact will be pushing it back to the JFrog. That's the general process, right? Now the build is successful. If I go back to the JFrog, now you should be able to see your artifact of version 1.0, correct? Now, what will happen, right? The developer is keep on working on the same project, right, to make it more better and better, right? Let's say the developer has done a few other changes to the source code. Now they will give you the latest code, correct? When the developer is giving the latest code, it's always the developer's responsibility to ensure that in the pom.file file they have to the developer has to update the version here. Let's say when you get a latest source code from the developer, right, the developer will be mentioning the version here, let's say 2.4, like that, and you get a latest source code. Your requirement is again you go and build it. You don't need to clean up, you can just build it. Now it is actually building the source code. This time this is the 2.0.
So if the dependencies have the latest version, then we have to update the settings and then deploy it again.
Give me a second there. And now if I come back to the JFrog, now the JFrog has the artifact of the different version too. That's how the JFrog will be maintaining multiple versions of the same artifact. Now if I look at here, now it has the 1.0 as well as the 2.0. The location is same, but it is maintaining two different versions here. That's one other advantage with the JFrog, maintaining multiple versions of the same source code or same project. Now, when it comes to the build process one more time, each time when the developer is modifying the code, it's the developer's responsibility to update the pom.xml file with the version as well as the dependencies as well, right? So if there are any changes that are happened to the dependencies, the Maven will automatically try to download them from the respective external sources. If there are no changes, if the dependency is already available in the local itself, then it will use it from the local repository. Just to avoid all this, whether it is using the local or whether it is getting it from the external dependencies, right? So as a safer side, right, as a safer side, it's always better to run mvn clean command so that it will try to clean up the local cache, and then it will try to download the dependencies as a fresh always. The only downside of this command is each time the build will take some time. I mean to say the overall amount of time the build process takes, right, will be little longer because it has to download the latest dependencies each and every time, right, because I'm using the clean command in the command itself. But it's up to the developer how they wanted us to specify that. If the developer says that, hey, use the MVN clean, yes, we will use. If the developer says that don't use clean, we'll not use. It's up to them on what basis, right, the build process will happen, right? But yeah, this is how it works. But most likely 90% the people prefer to use the clean just to avoid the not to use the old dependencies from the local, right? It has to get from the external dependencies. That's the safer side.